Hello, this is Hart Hagen, Louisville, Kentucky. Let's talk about what's wrong with fossil fuel-based fertilizers. We're going to review an article by the Union of Concerned Scientists and see what they have to say about the large-scale use of fossil fuel-based fertilizers in agriculture. We're going to talk about, I'm going to, critique where they're coming from, compare and contrast where they're coming from with where I'm coming from, and go from there. I want to first give you an overview of what I think, and that is this. Okay, what's wrong with fossil fuel-based fertilizers? 9 things. One is that they require a lot of fossil fuels. So that should be a concern to those who want to reduce the usage of fossil fuels for climate reasons. But we find that the people that are driving the conversation about climate change, they talk about transitioning to renewable energy, and supposedly that's going to reduce our fossil fuel usage. Not really, but you would think that they would talk about being able to reduce fossil fuels as it applies to agriculture, but they don't, and we'll talk about why. Number 2, fossil fuel-based fertilizer degrades the soil. We will talk about how fossil fuel-based fertilizer has a negative impact on soil health. And number 3, fossil fuel-based fertilizer creates a lot of water pollution because studies show that over half of this fertilizer that gets applied to the fields ends up not fertilizing the plants, but instead running off into the waterways and creating dead zones. You have something called algal blooms, which means lots of algae. The algae, too much algae, and then somehow that causes a deficit in the oxygen so that fish can't live there. Number 4, pardon the train horn, it's unavailable when we're live. Number 4, fossil fuel-based fertilizers are bad for the resilience of plants because it degrades the soil, and the soil does not deliver to the plants the nutrients that they need to be resilient. Number 5, fossil fuel-based fertilizers cause the need for more irrigation. Irrigation is the way that you get water to the plants, but the plants need more water, and the soil is, and the roots are not such that they can soak up the water that they do get. So fossil fuel-based fertilizers cause the need for more irrigation, which in turn causes the need for more fossil fuel usage because typically diesel fuel is used to run the irrigation. Number 6, fossil fuel-based fertilizers degrade the soil, and this is bad for the nutrition of the plant. We ought to be concerned about the nutrition of the plant because a plant that has sufficient nutrition is more resilient, for one thing. A plant that has sufficient nutrition is more nutritious to the person who eats the plant, or if an animal eats the plant and we eat the meat of the animal, then that we need to be concerned about that whole food chain from the soil to the plant to the animal to us. Number 7, the fossil fuel-based fertilizers are bad for the soil food web. Underneath the ground beneath our feet has a soil food web that has untold value. And fossil fuel-based fertilizers degrade the soil food web. We'll talk about that. Number 8, fossil fuel-based fertilizers are bad for the carbon content of the soil. Carbon in the soil is the gold standard. We talk about carbon being a bad thing, but carbon in the soil is a very, very good thing. It causes the soil to be spongy and absorbent. Carbon is the essential ingredient in soil organic matter. Soil organic matter makes the difference between whether you have soil that is good, that is able to absorb water, soil that is able to house that soil food web. So we should be concerned about the carbon content of the soil. And if fossil fuel-based fertilizers are bad for the carbon content of the soil, then we should seek to reduce the use of fossil fuel-based fertilizers and use them for another way. And all of which would be moot, all of which would be, we wouldn't even have to have this conversation if fossil fuel-based fertilizers were necessary for food production. I will argue that they are not necessary for food production, that we can produce plenty of food, good food, nutritious food without the use of fossil fuel-based fertilizers. So let's talk. I will now share with you, drum roll, the article from the Union of Concerned Scientists from earlier this year, and then we'll go from there. So here we have it. What's the problem with fossil fuel-based fertilizer? This is on the website of the Union of Concerned Scientists of the USA. And it was published December 5th, 2023. So it says, starting out, without the nutrients that fertilizers provide to crops, we would not be able to grow our food. I disagree. We would be able to grow our food without fertilizers, chemical fertilizers. Organic fertilizers, i.e. Compost, is a different conversation. You can say compost is fertilizer, but when I use the word fertilizer here, I'm talking about chemical fertilizers that are salts, and they require a lot of fossil fuels in order to produce. So it says, but one of the hallmarks of the U.S. agricultural system today is a massive overapplication of synthetic fertilizer to our soils, far more than our crops can actually use. So 2 points here. One is they're saying that the problem is over-application of synthetic fertilizers, the over-application of chemical fertilizers. I'm saying that any amount is too much, and we could do without them entirely. We could grow more nutritious food without chemical fertilizers. They're just saying that we need them, but we don't need as much as we use. So let's go on to see what else they have to say. Much of that unused fertilizer pollutes our air, water, and climate. The giant chemical companies make and sell all that fertilizer. The giant chemical companies that make and sell all that fertilizer maximize their profits by keeping farmers hooked on their products at the expense of our environment and vulnerable communities. All of this is true. So 2 points here. One is these fertilizers pollute our air, our water, and our climate. And the second thing is that we are not using these because of anything that is inevitable or unavoidable. We're using fossil fuel fertilizers in massive amounts because the chemical companies do good marketing, but more importantly, the chemical companies have lobbyists that are able to enact public policies that are good for the fossil fuel fertilizer company, but not good for the public, not good for the farmer, not good for the communities around which the communities that are near the farms, and also not good for the wildlife. They're not good for the waterways, so they're not good for the fish. They're not good for the birds, butterflies, and bees that might otherwise like to fly over these places where we have massive crop fields that are in monocultures. A monoculture is the enemy of nature. Monoculture and nature are inherently at war with each other, at odds with each other. Next point, chemical fertilizer is big business. The mineral nutrients that plants need most are nitrogen, phosphorus, and potassium. This is NPK. N for nitrogen, P for phosphorus, and K for potassium. Along about the 1950s, we started to get much more in the way of fossil fuel-based chemical fertilizers. So we have nitrogen. Nitrogen is essential for all plants, but the nitrogen that comes in a bag is not the only way for plants to get nitrogen. We need to have biological systems in the soil so that the soil is able to deliver nitrogen to the plant. Instead, we dump this fertilizer on the ground and in the ground. The fertilizer does a couple of things. One is it kills off the soil food web that would otherwise deliver nutrients to the plant. The other thing it does is that it makes the plant lazy. The plant says, okay, I've got all this nitrogen, so I don't need to do the things that I would otherwise have to do in order to obtain nitrogen. What I would have to do in order to obtain nitrogen, if I weren't getting all of it from a bag, is that I would have to take carbon out of the air and exude some of that carbon in the form of sugars throughout the roots of the plant, so that the sugars cause the soil biology to come running because, hey, we've got something to eat now. So the plants do that unless you disable those processes with nitrogen-based fertilizers. So let's go back to the article. It says in ecosystems, so it's going to compare and contrast ecosystems with industrial systems. So in ecosystems like forests and grasslands, plants get these nutrients, nitrogen, potassium, and phosphorus. They get these nutrients as part of a natural cycle. Now, we could have that natural cycle as a way that we do agriculture, but we don't, because powerful companies are able to shape our agricultural system in a way that suits them, even though it's bad for farmers, bad for consumers, bad for wildlife. Animals excrete nitrogen in their manure and urine, and together with the breakdown of dead and decomposing plants, these nutrients are incorporated into the soil for the next growing season. I think this sentence represents an unsophisticated understanding of how plants get nitrogen. What they didn't mention here is that soil bacteria facilitate the process of delivering nitrogen to the plant. Soil bacteria, fungi, protozoa, nematodes, microarthropods represent most of the soil food web that, if it's allowed to work, will deliver nitrogen to the plants, and will do so in a way that is more efficient in terms of energy required and the water required. Reading on. It says, many farmers and gardeners mimic this natural cycle when they apply manure and compost as fertilizer, or when they raise crops and livestock together. This is true, no problem. But the vast majority of agricultural production in the United States today is fueled by synthetic fertilizers, products of dirty industries and polluting factors. I'm pleasantly surprised by how the Union of Concerned Scientists is able and willing to kind of talk about the economics involved here. It takes some courage and some integrity to talk about powerful companies and powerful industries in this way. Reading on. It says, phosphorus and potassium-based fertilizers are made from mined minerals, while nitrogen fertilizer is manufactured using fossil gas based on a century-old method that originally produced nitrogen for use in explosive such as TNT. So what they're talking about here is the the Haber-Bosch process. The Haber-Bosch process was developed in Germany in the early part of the 20th century. Fritz Haber, and I don't remember Bosch's first name, but they developed this process where previously, if you want nitrogen, you have to rely on more natural processes. But then they discovered how to take nitrogen out of the air. Now, the air that we breathe is like 78% nitrogen. There's a whole heck of a lot of nitrogen in the air that we breathe. Incidentally, fun fact, when a scuba diver goes down or when a scuba diver is down there and then comes up too fast, when they get the bends, that's because of too much nitrogen in their blood. But every breath we breathe has nitrogen in it, but it's inert in the sense that it's these two nitrogen molecules that are bound together. It's a very strong bond. It's hard to break that bond into the separate nitrogen molecule, take those nitrogen atoms and put them into different molecules so that you can store that and ship it to the farm. Store that in a bag, ship it to the farm. And that's how it was the Haber-Bosch process that pioneered the process of, taking lots of energy and using that energy in order to package nitrogen in a form that is usable for both farms and explosives. They mentioned here that when you take that nitrogen, you can use it to make fertilizer or you can use it to make explosives. That's why some amateur explosives are made from fertilizer. So, reading on, it says the fertilizer industry was born in the early 20th century. Synthetic fertilizer used per acre of farmland in the United States skyrocketed after 1960, reaching a peak in 1981. Nitrogen fertilizer use has continued to climb, according to sales data, with major commodity crops such as corn using the largest share. So it's true that most farmers today wouldn't know what to do without nitrogen fertilizer. It's something that most farmers did not use prior to the 1950s. But then, the process, the 1950s brought about the advent of industrial agriculture such as we see it today. Before that, farmers relied on more natural processes. So, reading on. Let's find something good here. Let's go on down. It says fertilizer overuse damages soil and pollutes our water and communities. It says the fertilizer industry has succeeded by convincing farmers that its products are needed to increase and maintain crop yields. Let's go on down. I want to get more into the soil. Well, here's something good. In addition, the nitrogen and phosphorus in fertilizer runoff feeds algal blooms that threaten bodies of water, such as Lake Erie, with regularity. Agricultural runoff is the leading cause of water pollution in rivers and streams. So if we want to help our rivers and streams, we would use less fertilizer for one thing. We would also protect the health of our soil better, because healthy soil is able to capture rainfall. Soil that is able to capture rainfall is able to filter and clean the water. Fertilizer has a powerful impact on our climate. This is true, but they're going to talk only about the carbon angle on climate change. I believe that carbon dioxide is not even the major cause of climate change, climate irregularity, climate chaos, climate instability. I think natural systems such as forests and grasslands and even regenerative farms are potentially a much greater regulator of climate. It does talk a little bit here about nitrous oxide, which is if you're concerned about greenhouse gases, we ought to be concerned about nitrous oxide. Nitrous oxide is a major byproduct of the application of nitrogen fertilizers. So, why aren't the mainstream climate people talking about this? And the reason is that they're afraid, in my opinion, they're afraid to confront powerful industries. So let's go on. Yeah, here now we're talking. Let's get to agroecology. It says agroecology and smart public policies can solve our fertilizer problem. So it says the scale of our fertilizer problem is vast, but so is the potential and the opportunity to fix it. I completely believe that. The problem is big and the solution is big. Researchers in 2021 mapped 20 excess nitrogen fertilizer hotspots across the country. Well, they're just going to talk about limiting it, but I want to talk about the science of agroecology. Sees farms as ecosystems rather than factories and offers proven solutions. Unlike industrial farming methods such as monoculture, planting the same crops in fields year after year, frequent soil tilling that degrades soil health and oversaturating the land with polluting chemical fertilizers, agroecology emphasizes sustainable farming practices that do not harm the environment. So it says, one problem is monocultures. We can talk about monocultures. So monoculture means one crop, whether it's corn or soy or wheat, it's one crop as far as the eye can see. It's not natural. It's not the kind of thing that is necessary for growing good food. In fact, they only grow junk food. When they have one crop as far as the eye can see and they're growing it in bad soil, that is a formula for junk food or no food at all. Sometimes corn is used to grow junk food in the form of high fructose corn syrup, which is a major sweetener. It has no nutritional value whatsoever. Sometimes corn is used to grow animal feed, which is, corn and soy are used to grow animal feed, but we could be feeding our animals something that does not need to be shipped in from hundreds of miles away or thousands of miles away. Sometimes corn and soy, especially corn, is used for biofuels. Biofuels meaning corn ethanol. 10 or 15% of every gallon of gas in most places is made from corn ethanol. It's bad fuel, and it has a bad carbon footprint. It is absolutely useless, and the only reason this industry exists is because of public policy, because the taxpayers are heavily subsidizing this. And, so whether corn is used for junk food or animal feed, or whether it's used for biofuels, it does not have to be this way. There's a better way, and that's from regenerative agriculture. So let me read another paragraph. It says that UCS, Union of Concerned Scientists, is UCS. UCS Science and Advocacy have made a solid case for federal farm policies that do more to move agriculture in this direction. In other words, agroecology, where the farm is more of an ecosystem, and the ecosystems that we need can be located on farms. There's no reason why our farms cannot be ecosystems. So how can a farm be an ecosystem? And that is, look at the principles of soil health. If you want to know how we're treating the earth, then look at how we're treating the soil. earth and soil are sometimes synonymous. We want to talk about saving the planet, but we don't want to save the soil. So if you want to know how to save soil, let me run through the 5 principles of soil health, and then I'll wrap it up, or 7 or 8 principles of soil health. So first of all, why do we want good soil? We want good soil because good soil captures rainfall. Good soil is largely defined by more carbon content in the soil. When the soil has more carbon, then it is able to absorb more water, because soil organic matter makes the soil spongy and absorbent, and it's able to absorb more water. When the soil has more water in it, then that makes it able to have more, well, to grow more plants. So it's a virtuous cycle. You allow the plants to inject carbon into the soil, allow the plants to nurture the soil food web in the soil, then the soil food web then nurtures the plants. So, and when the soil is good, the soil absorbs more water. When the soil has more water in it, then the soil food web has more water and the plants have more water. It's a virtuous cycle. So let's go through the 5 principles of soil health. Number 1, no disturbance, meaning no tillage or plowing. So plowing is, okay, I see Louise Mitchell on the feed. Louise, I'm going to respond to your comment in just a minute. So I was going to run through the principles of soil health. Number 1, no tillage, because that destroys the soil structure. Number 2, no chemical fertilizers, because chemical fertilizers literally poison the soil food web, and you need a soil food web in order to have good soil, in order to have the benefits of good soil. Number 3, minimal or no toxic pesticides. It's possible some pesticides, like traditionally, I'm not saying all pesticides are bad. I'm saying almost all modern chemical pesticides are bad because they're toxic for people, they're toxic for wildlife, they degrade biological diversity. We need biological diversity in order to have regenerative farms. So avoid tillage and plowing, avoid chemical fertilizers, avoid toxic pesticides. Number 3, armor the soil. So armor the soil means having the soil covered. So if you've planted something and there are bare spots in there, you want to have some type, you want to have mulch or crop clippings, some type of organic matter. So here's a plant and here's a plant, maybe here's a row of soybeans, a row of corn. You want to have wood chips or crop clippings or some type of, you don't want to have bare soil, no bare soil. Another thing, you want to have living roots in the ground. Plants are the best thing for soil. You want to have living roots in the ground because the living roots are going to take that carbon dioxide out of the air, turn it into sugars, exude some of those sugars through their roots, and then they jumpstart the whole soil food web. And the last thing, last 2 things, as far as the principles of soil health, you want to nurture diversity. Diversity is good. Diversity of plants is good. It's better to have 8 different species of plants or 16 different species of plants if you can, rather than just having only one type of plant. Monocultures are bad, diversity is good. Lastly, and part of the principle of diversity is you want to incorporate animals if you can. This article from the Union of Concerned Scientists talked about how farmers used to do it in the old days. You have a crop field, but when you don't have a crop field, you might turn your livestock loose on the crop field so that they can take some of that organic matter and some of those plants, eat them, cycle them through their digestive system, poop, pee, add nitrogen, add biology. There's all kinds of biology in the gut of an animal. And if you can graze livestock, then that's a good thing. Otherwise, you can utilize animals in the form of, when you do compost, sometimes your compost is going to have worms. Sometimes your Like when you have good soil, it's going to have not only the the bacteria, the fungi, the protozoa, the nematodes, the microarthropods, but you're also going to have worms. You're going to have birds. Birds come in, they eat the worm, they poop after a while, and so that's incorporating animals. So if you look at if we did this on our landscapes and on our farms, it would avoid both flooding and drought. It's counterintuitive. Flooding sounds wet, drought sounds dry, but flooding and drought are flip sides of the same coin. We have flooding and we have drought because the soil is not able to absorb the water. And that's all I have to say about that. Now let's get to Louise Mitchell's comment. I agree wholeheartedly, Hart. Actually, it is much healthier for the soil to use cover crops and restore microbes in the soil. So thank you, Louise, for that comment. One thing she's referring to there is cover crops. It would be great for so many reasons if farmers and gardeners were to use cover crops instead of letting the soil be bare. So a cover crop is a collection of plants that you sow onto bare soil. This is, Gabe Brown says, let the soil have living roots. You want living roots in the ground. Even if the plant, let's say it's the fall and you've harvested your crop, even if the plant, so you sow the cover crop, even if the cover crop doesn't have a chance to grow to maturity, it's still a very good thing because any growing it does is going to take carbon out of the air and put it into the ground. It's going to nurture the soil food web. You're going to have more porosity or pore spaces in the soil because, for one thing, those roots are going to create some pore spaces, but more importantly, the carbon the plant takes carbon out of the air, puts it into the soil. It gives the soil a chance to gain in soil organic matter. Soil organic matter makes the soil spongy so that it can absorb water. Soil organic matter is a framework or a substrate or a lattice it's a structure that allows so many living things to grow and thrive. Not least of all, the soil is absorbent. When the soil absorbs the water, for one thing, you don't have the flooding. When the soil absorbs the water, you're not as vulnerable to drought. And when the soil absorbs the water, it nurtures the plants and the soil food web. This is almost never discussed in the mainstream of agriculture, even though it's more of a topic of conversation as of late. And it's almost never discussed among anybody who cares about climate change. It should be discussed in the context of climate change. Why? Because for one thing, bad soil is a major source of carbon, whereas good soil is a carbon sink. If the soil is quality soil and growing in quality over the course of time, then it's going to have more carbon over the course of time. This is just not discussed among I like to pick on the United Nations and the New York Times, these major prestigious institutions that claim to be telling us what to do about climate. They almost never talk about soil or the carbon content of the soil with any regularity. And I think the reason for that is that they know how not to bite the hand that feeds them. They know how not to talk about things that are going to offend their owners and their sponsors. That's about all I have to say. Thank you so much for joining me. Have a wonderful day.